Hello everyone, welcome to our presentation. Today, we will be presenting our movie recommendation system project. My name is Gla Wanisusombat.
My name is Big Tanashobli.
My name is Don Cancel.
My name is Jun Jakapat Kasot.
Our project uses both content-based filtering and collaborative filtering to recommend movies to users.
The main objective of our project is to build a functional movie recommendation system using real-world data. We use the MovieLens dataset, which contains thousands of movies and user ratings. Our system recommends movies based on two things. 1. The content of the movies, such as its genres. 2. The behavior of users through rating correlations. This allows us to give more accurate and personalized recommendations.
Our system has several main components. First, data loading and merging using pandas, genre processing using count factorizer, cosine similarity for content-based comparison, user movie rating matrix for collaborative filtering, and finally, a hybrid method that combines all of them. In simple terms, the system analyzes what the movie is and what people think about it.
Our content-based filterings use the genre of each movies. For example, if you like Toy Stories, the system looks for movies with similar genre combinations. The collaborative filterings check users who rate the same movies. If many people who like Toy Stories also like Toy Story 2, the system learns these patterns. Finally, the hybrid system adds the scores from both methods to generate stronger recommendations.
Hybrid recommendation systems are important because they combine the strength of both content-based and collaborative filtering, creating a more reliable and well-rounded recommendation experience. Content-based filtering is good at understanding what a movie is, for example, its genre or style. But oftentimes, it becomes repetitive and only recommends very similar movies. Collaborative filtering, on the other hand, learns from users' behavior, but struggles when a movie is new or there aren't enough ratings.
By merging both techniques, we reduce those weaknesses. This system can still recommend similar movies even if there are limited ratings, and at the same time it can leave patterns from users to diversify the suggestions. This leads to better accuracy, more variety, and a stronger personalization. This hybrid approach is not just academic, it mirrors what real-world platforms like Netflix, YouTube, and Spotify use. So implementing it in this project brings the system closer to how modern recommendation engines actually work.
Let me show you how the system works. The programs first ask the user to enter the movie title, for example, Toy Stories, followed by the year it was released. Once entered, the system calculates the most similar movies by genres, the most correlated movie based on ratings, and then merge them into final hybrid recommendations. The program prints the top results along with similarity scores. It's also identified the single best recommendation, like because you like Toy Stories, you may enjoy Ants.
Now let's evaluate our project based on the rubric. In terms of completeness, the project satisfied all the requirements components. The data loading and cleaning, content-based filtering, collaborative filtering, hybrid scoring, and user input and output, and also an optional visualization using Matplotlib. The program works end-to-end and produces meaningful recommendations from real data, making it fully complete.
This project also reaches a good level of difficulty. Some of the challenging parts include using count factorizer to transform genre text into numerical vectors, computing cosine similarity across thousands of movies, building a user movie rating pivot table, handling missing data and filtering movies with low rating counts, computing movie-to-movie correlation for collaborative filtering, and combining both approaches to a hybrid system. Integrating multiple machine learning techniques together shows a solid understanding of the concepts.
In terms of code quality, the script is structured into clear functions such as loading data, computing similarities, and generating recommendations. The program uses descriptive variable names, proper error handling for missing movie titles, and is well organized. We also avoided reluctant calculations and made use of efficient pandas and scalar methods. Overall, the code is readable, maintainable, and follows good structures.
Of course, there's still areas for improvement. Some limitations include the collaborative filterings depend heavily on rating densities. Movies with very few ratings need to be removed to remove the noise. The hybrid model uses equal weight instead of optimized weights. The system currently runs on the command line only. Future improvement could include adding search autocomplete for finding movie titles, deploying the system on the website or GUIs, and implementing adjustable weighting for hybrid scorings.
To summarize, we successfully built a hybrid movie recommendation system that uses both content-based and collaborative filtering. Our system is complete, functional, and meets the requirements for difficulty and code quality.
Thank you for listening.
Thank you for listening.
Thank you.